Hello, I am Brian Corbridge, and this is my presentation of Lab 1 charged tape. As an introduction into this lab, the purpose of it is to stimulate and examine excess charged particles in a piece of tape. We will also investigate how this piece then interacts with other objects in order to determine its charge and force from said charge. In order to accurately understand what is happening in this lab, we must rely on three fundamental principles. First of which being Newton's second law, force equals mass times acceleration, Coulomb's law, and gravitational force, which is uh, 9.8 meters per second squared in the downwards direction. In the lab that I'm about to go over, we were able to confidently gather that both pieces of tape that were used had a net positive charge because they repel each other, and that the charge of each tape was roughly 1.167 times 10 to the negative eighth coulombs, and that's a result of the 7.28 times 10 raised to 10th electrons that were lost. So for the first part of the lab, we stacked two pieces of tape onto each other and then placed that on the table. We then quickly yanked off the top piece of tape, stuck it to the edge of a table, watched as it dangled off, and then when we placed our hand near it, the tape was attracted to our hand, and even though it wasn't the sticky side facing our hand, it almost acted like it was because of the electric force attracting it to our hand, and we also put other charged objects around it, and we found that because it was attracted to our hand, and we know our hand is negatively charged, we knew that the piece of tape was positively charged. For the second part of this lab, which is the part that we are going to be simulating in GlowScript, we duplicated we had a similar setup as the first part where we got two pieces of tape stacked on to each other and put on a table. We actually did that twice, so we would have two pieces of tape that we could yank off the top. Um, we put the first tape, uh, we attached one end of the first piece of tape to a raised platform, and then the other end to another raised platform, and then a bit of like a valley in the middle. And then we got the second piece of tape, and we held it underneath that first piece. And from that, we saw that the slack from the top piece was almost inverted, and it was being repelled from the bottom piece of tape. So it looked like it looked like if it wasn't attached to those platforms, that it would be flying away in some sense. Given that both pieces of tape had identical positive charges, because we did the same thing to charge it, we yanked it off another piece. And both pieces were 20 centimeters long, 2 centimeters wide, weighed about the same, and we also knew that it was held about 0.025 meters apart. With that information, we were able to calculate the net electric force needed for the tape to defy gravity like it did. Here is my GlowScript code simulating what I just showed in the second part of the lab. It's nothing special. It's basically just the math I did on my own, just in Python. You can see up here on top is going to be like the initial conditions and setting all the variables. And then this code will then produce what's here on the left, and it'll give us all this information on the bottom. Like I said earlier, the results that the code produced were luckily extremely similar to what I calculated myself. Um, any slight discrepancies, though, could be attributed to things like air resistance or even just that process of yanking the tape, which would charge the tape, and then placing it down. That would then cause it to react to things in the surroundings in unwanted ways. Uh, Also, in order for this to work, we have to make a few assumptions, like neglecting what I just said about air resistance. And we also had to treat the two pieces of tape like point particles, otherwise it'll be a little too complex. Lastly, here are some questions that I was asked to go over. If electrons and protons switch charges everything that was previously positively charged is going to become negatively charged. Everything that's negatively charged is going to be positively charged. And it is important to not handle the charged tapes as much as possible. And that is because if you touch it too much before the experiment's actually carried out, it's going to lose its charge by interacting with other charged objects.